Next up is Stewart Dewar. Stewart, if you would share your screen, I'll do the introduction for you. Okay, great. Okay, just share your screen now. Okay, so the next presentation is from Senstar. The title of the presentation is Physical Security Technologies for Electric Utility Infrastructure. We're very pleased to have with us Stewart Dewar. Stewart is a product manager with Senstar, which is involved in physical security solutions, including perimeter intrusion detection and video management and analytics. This morning, Stewart will examine the technologies implemented to help electrical facilities meet critical infrastructure protection requirements to deter, detect, delay, assess, communicate, and respond to physical threats. So, Stewart, I see your screen there. If you just do the full screen.
Oh, sorry. Okay, let me unshare because I shared the wrong screen. Sorry.
Oh, okay, that's fine. We'll
new share screen 2. Share.
Okay.
Sound good? Look good?
Looks great. Okay.
Okay. Well, thank you, Randy. And thank you for your attention this morning. I think I have to say good morning, good afternoon, and I think good evening as well.
It's a good idea. Yeah.
So within the context of electricity forum, the subtitle of this presentation could be "And now for something completely different," because we're not going to talk about generating electricity or controlling it or switching it, but how to secure the electrical infrastructure and all the technologies that can go into helping into that equation. So we'll start with a bit of a backgrounder on this is what I'm going to talk about, the challenges, the different elements of the physical security solution, technologies, and then we'll have time for Q&A at the end. So the challenges. So this is, our understanding, or the collective understanding of the physical security providers of the challenges that that exist for the electrical utility industry. So first of all, we are trying to ensure the continuity of a critical resource that underlines modern society. And I love that first bullet because it sounds so completely over the top and ridiculous, but it's actually true, of course, that everything runs like we couldn't survive for very long without our electrical grid. Physical security is also involved in supports workplace safety and also safety of the general public. Many of you will know that there are government requirements for certain classes of electrical infrastructure to provide physical security, and obviously we have solutions to address that. Then there's the more day-to-day, like they're minimizing direct losses to theft and vandalism, right? This happens, and we have means to reduce that. We need and have solutions that complement operational workflows. We don't have to make this into like a Fort Knox with a moat to get effective security. And we need to have cost-effective solutions because there's many different environments. You've got generating stations, which are very large. You've got lots of transmission substations, and many distribution substations, in the hundreds of thousands or millions, which are small and need cost-effective solutions and have a special attribute where they're sometimes adjacent to residential areas, so that some solutions that would be pertinent for other environments are not pertinent for that environment. And then, of course, there's other high-value assets not directly to do with the electricity system, but storage yards, solar farms, etc. So what are the threats? What are the direct threats? And again, it's our understanding of the industry that one of the most common problems that's faced is just out and out theft, right? Like there's seen to be valuable resources in electrical infrastructure facilities, and thieves want to go in and get it, right? And there's further understanding that the it's not so much the direct loss necessarily, but the subsequent effects, right? If someone goes in and rips up the grounding grid of an electrical substation, maybe workers show up to do their job and they're not really necessarily aware of this, then they can land in an unsafe environment. So we want to stop that. Obviously, sometimes unfortunate things can happen when people who don't know the risk, attempt to undertake these steps. Bad things can happen. Vandalism, that's a threat more or less similar to theft, but without an economic rationale behind it. And then there's the threat of terrorism, hacktivism, which we all deem to be low probability, but it's a high impact event. I mean, people have they imagine the nationwide coast to coast blackouts that would be disastrous for everybody. So this is kind of the motivation as to why what we understand the motivation to be as why these facilities should be protected. Why technology? Like what does technology bring to the party? Well, classically, for any kind of secure facility, you can put up a fence, but the fence by itself isn't really going to do that much good. It's easily overcome. It's not that much of a deterrence. And also, the threats that you have, they're distributed. They're, again, many sites. They're constant 24/7 threats. Having a guard force is cost prohibitive and rarely, sometimes actually done, but not often, and very expensive when it is done. So we need a sensible combination of physical security technologies to make this work. And it is a point worth making that the cost of some serious incident, the damage, the service loss, the liability, the fines that can come with such an incident, a security incident, can dwarf the cost of the equipment that could have prevented it. So that's a bit of background. So in many countries, and particularly in North America, there's a definite focus on physical security for the electrical grid. The North American Electric Reliability Corporation, NERC, has put out regulations that guide the provisioning of this security approach. And in their recommendations, they break the elements of security down to these 6 elements: deter, detect, delay, assess, communicate, and respond. So this is somewhat of a layered approach to the security. And however sophisticated or simple a system is, it typically will have these different elements, just to different degrees and to different levels of complexity. So we're going to go look at the problem through the lens of these elements. So here we have the elements here: deter, detect, delay, assess, communicate. And I've added little 2 layers to deterrence where you have static deterrent elements and responsive deterrent elements, and we'll talk about that. So what about the technologies? What are they? Well, lighting, it's basic but important, and there are some options in how you do it actually. Public address systems, sirens, strobes come in kind of to that second level of deterrence. Something is happening and you want to let people know that they're under observation and they've been noted. You can do that with those systems. Then there's perimeter intrusion detection systems, and we're going to talk a lot about that because there's many different varieties. They are important to ensuring there's no unauthorized access to the location, and they contribute to the detection primarily, but also somewhat to the deterrence. Access control system, you need your locks, and if you have the right kind of connectivity, they can be electronically activated, so you can have standard access control mechanisms, card readers, tokens, fobs, whatever, to allow access to the facility. From a more on the security side, is the video management system. Again, not all systems will have a video management system per se with cameras and whatever, but most of the critical sites will, and this is the direction of the industry as this technology becomes more affordable. And then we have the security management system aspect, which is kind of the classic show the event to an operator, let him take some action, let him activate the response forces, keep records of what's happening, et cetera, et cetera. We'll talk a bit more about that. So this is the kind of menu of technologies that go into the layered approach. So deter, deterrence primarily, that's the classic physical barrier, fences, walls, bollards. Technology element that relates to deterrence, the static deterrence, I would say I would introduce the lighting element. Now, the traditional approach is centralized lighting. You light up the whole area, the perimeter, that's the point of attack, gets some light from the central area lighting. It gets kind of leftover light from that, so to speak. More coming on stream, I would say, is distributed perimeter lighting. And it's really enabled by LEDs, right? Now you can cost effectively have these distributed lights, which has a number of advantages for security applications. And these are the distributed luminaires here, approximately every 20 feet down this perimeter. So with the distributed perimeter lighting, you get better uniformity of light, which helps not only the camera system, but also the responders that would come in and that would respond in the case of an incident. Unbalanced light creates shadows that make it hard for people to see what is going on there. So better uniformity of light, the better for cameras and people. This type of approach has the benefit of less light pollution, more neighborhood friendly, as we would say. And I guess to tie back to the previous speaker, there's more and more concern, globally about pollution of all kinds. Before we were talking about the greenhouse gas issues, but light pollution is increasingly of concern. And relative to the centralized lighting, there's distributed perimeter lighting, has a lot less light pollution elements. And it's relatively economic to light up your perimeter this way because it's low voltage. So that eliminates a lot of restrictions in who can do the work, grounding, conduit, et cetera, et cetera. Now, yet another evolution of this is perimeter lighting that also has the sensing built into it. So the same kind of idea with distributed LED luminaires along your perimeter, but this example that's being shown here actually has a sensor built into each of the luminaire heads, and that enables some creative and flexible interaction between the detection element and the lighting element. Most particularly, the lighting can respond to an event, so it can bright up when it detects a deterrence, and or strobe, flash, which draws attention for the intruder and the responder, and is actually also a kind of an inhibitor, because when this strobing happens in the middle of the night, when most of these kind of attacks would take place, it's overwhelming and confusing, right? So there's a delay element generated by the strobing of the light. So all of these things can be done with the combination of the sensor and the light. So that's a bit about the lighting aspect. Detect, like I said, there's a vast array of different technologies that support the detection function. And we'll talk about them to different degrees. First and foremost is fence sensors. We'll talk about them. Buried cable-based sensors, microwave sensors, passive infrared, active infrared, which are also sometimes called photo beams, electrostatic sensors, which are very specialized. I'll show you the picture. You'll see how particular and specialized that technology is. Radars are gaining more usage and attention for this field, as is video analytics. Using the camera streams, analyzing them for the detection process. And then we have a couple of what I'll call emerging technologies. One of them being Lidar, and the other being the idea of fusing different sensors together, sensor fusion. So that's what we're going to talk about for the next few minutes. So fence sensors. As illustrated in the picture, typically with the fence sensor, there's some cable of some type attached to the fence. And they will detect attempts to climb, cut through, or otherwise dismantle the fence to gain access. And sometimes I say it will detect fence hoppers and fence choppers, right? However they're trying to get through, the fence sensor will detect that. So different types. There is cable-based types where the cable itself has properties that enable it to detect vibration, enhance the intrusion, and that can be conductive or fiber. There are types that use distributed accelerometers. So there'll be like a lump along the cable where there's an electronic assembly with the MEMS accelerometer typically in it, or a piezoelectric accelerometer in it. There are actually mechanical motion sensors in existence still. Some people might have heard about this. Sometimes they're called shaker ball systems, where if the fence shakes enough, a little ball is moved and either makes or breaks an electrical contact, and that detects the motion. It's kind of like an accelerometer with a 0 or 1 output, either no acceleration or enough acceleration to move the ball. And then again, as referenced before, there's the combination of accelerometer detection with lighting. That's it. So what are some of the points relative to fence sensors? Well, they're relatively inexpensive. They're on the scale of the technologies that one would put in place for detection. They're on the more cost-effective end of the scale. You don't need a lot of infrastructure other than the fence itself, because the cable moves along the fence, and many of these sensors don't need too many power points or communication cables, because they support that internally with it. And there's a wide variety of options, tons and tons to choose from. Something to consider, with the fence sensor is the fence needs to be kept in good shape. It doesn't have to be great, just has to be good. And that means that all the fixings that, keep the fence fabric to the post and to the top rail and bottom rail need to actually be there, and tight as they should be. And shrubbery and trees need to be cleared away from the fence, because that will, impact the fence in windy conditions and create nuisance alarms. So this is some of the considerations with a fence sensor. And here's a couple of examples. Using a conductive type of cable with a distributed processor. And again, you attach that cable directly to the fence. This is a fiber optic system, which really here all you can see is the cable. There's a spool of it there, but then it's distributed along the fence. The fiber optic systems typically are centralized. The processor is centralized, so there's no distributed processors outside. So for relative to electrical, they have no possibility of induced voltages on the sensing cable. And there's no grounding requirements. There's really nothing outside other than fiber optic cable. Now they're a little more expensive, but that's the trade-off, that's the choice people have, to go to a conductive cable system or to a fiber optic system. And then again, the accelerometer-based system, which is very effective, particularly if existing lighting needs to be improved, right? Then you've got the two-in-one approach that enables you to improve the lighting and get the detection function in one go. This particular system that's being shown here has an additional feature where the communication from all the luminaires and the alarm data that needs to get back to the head end location, it's all done wirelessly over an encrypted wireless mesh network, which cuts down on the amount of wiring that you need to put out into the field. All you need is very simple, low voltage power cables. Buried cable sensors. Now, this is a class of technology that can be very effective. As the illustration is showing, the basic idea is that cables are buried in the ground underneath where you want the zone of detection to be. There's different kinds of these cables, electromagnetic, that actually use a processing technique and a concept that's very, very much like a radar, with specialized cables that act as antennas. Force sensitive, where there's liquid filled tubes or force sensors, buried in the ground. Vibration sensitive, so fiber optic cable or distributed accelerometers can be put in the ground to detect the vibrations of people walking over this. So it can be very effective for many circumstances. What's good about the systems? They're considered hard to overcome by an intruder because they're covert. The intruder doesn't necessarily know that they're there. So he doesn't know to take countermeasures because he doesn't think he needs to. Some of them offer a well-defined zone of detection, and that's very important because with any kind of perimeter system, you want to be able to say, I get the detection here, but over here where people might be or cars or whatever, I don't want detection. So with certain of these, you get a very clear, well-defined zone of detection. Generally not too affected by presence of vegetation. So you don't need to go to extremes to keep the system maintained or your site maintained. Cons. Not cons, but considerations. They're at the upper end of the cost spectrum for the equipment and for the installation, right? Because you got to dig and put them in the ground. No matter what the type, you need several meters or 15 to 20 feet of clear area where there is not going to be any traffic, no people, no cars, to set off, create nuisance alarms. And as I mentioned, they required the simple act of digging, around many electrical sites is just, forget it. It's a no-no, or at least it's not a no-no, but it's very much frowned upon or preferred to be avoided, right? So if you want to minimize digging, the buried cable sensor is not for you. Microwave sensors are conceptually by far the simplest type of sensor that exists, very common, have been around for decades. Basically, you set up a transmitting element and a receiving element, transmit microwave RF energy, either around 10 megahertz or 10 gig or 24 gigahertz from one to the other. And this will create an approximately cigar-shaped zone of detection in between them. And when someone goes in between those into that zone of detection, the disturbance to the transmitted signal will be noted and raise the alarm. What are the types? Well, there's bistatic, where that's shown in the drawing, separate transmitter and receiver. And a monostatic, where actually there is kind of like a radar where the transmitter and receiver are in the same spot, and the signal is reflected back to the source, which is simpler from an installation perspective because you only need to put something in one place. But the range of those is limited, and they're more expensive. So looking at pros and considerations, the microwave sensor is relatively low cost. It provides what is called volumetric detection, in the sense that the detection zone is a volume. So it's not just a surface, like the ground or a fence. So this is seen to be a preference. Anything that creates the volumetric detection is seen to have create a higher degree of difficulty to avoid. So that's a good thing. They're relatively simple to set up. Then, okay, considerations. Well, like the buried cable system, you need a decent sized clear zone, right? At least 3 meters, 10 feet. Very sensitive to the presence of vegetation. So wherever you set up the microwave system, you need to cut the grass, shorter than like 10 centimeters, I think we say, 3 inches. So it needs to be very clean that way. And, to do a full perimeter, you need lots of these items, and you're going to have a lot of cabling for the power, and for the data. And to access them wherever they are, that's, you're going to need to do some digging and put conduit in place. So there's a lot of infrastructure required for the microwave systems. Next up is the infrared. And there's 2 main types. Well, there's a passive, which we're going to talk about on this slide, and then the active coming up later. But so passive infrared is detecting body heat. Now, that's the primary mechanism. Some are augmented with a microwave, a short-range microwave system, kind of analogous to what we just talked about, built into the one head. What are the types? There's a tremendous range, there's a tremendous variety in the range, right? You can get like, door opener kind of range, which gives you a few meters, maybe 10, 15 feet, or, longer range systems up to, 30 meters, about 100 feet. Pros, considerations. These are relatively low cost systems. Again, they're volumetric. They create a detection area that fills a volume. Relatively easy to set up. And very effective and very often used for, specific areas of a perimeter. The gate area, say, or in front of an entrance to a building, because they're easy to put in place and effective for that purpose. Considerations, they are limited, which is kind of the same time as a pro, that it covers a limited controlled area. If you want to do a whole perimeter, then it tends to break down. You need too many of them. There's too much setup, too much cabling. The probability of detection of the passive infrared is affected by temperature. The hotter it is, the lower the probability of detection is. So you can do your testing, the so-called walk testing on a certain day, and everything's great. And then, a heat wave comes in and you test it again and it's not so great. The range is reduced, or it's just not getting the detection that it should be. So that's a passive infrared. The active infrared, whole new level of higher level of sophistication. Narrow beams of infrared light, typically laser light, I believe, is transmitted between transmitter and receiver pairs. Often you'll see IR posts, because multiple pairs of transmitters and receivers will be stacked up into a post-like object that houses them, and you put them in place along the perimeter. And they can be stacked up to different heights. You can have posts that are 2 meters high, 7 feet high, or short ones that would be 2 feet, 1 meter in distance. There's a great variety in the number of beams in the pattern. So as illustrated here, this is a very elaborate scheme with multiple transmitters, multiple receivers. Each transmitter is being sensed by multiple receivers. So this is an approach that attempts to do some sizing of the intruder. Like I'm looking at the bottom one here. Like unlike the top one, which is like kind of the simple low end, where if a bird goes between the transmitter and the receiver, it creates a nuisance alarm. That's not going to happen with the lower system, or even like a small animal, like a dog, would not be typically fooled by such a system. So lots of variety in the level of sophistication of the systems. And one of the strong suits of the system is that it creates a very narrow clear zone, or actually detection zone. So you can put it in narrow areas. You've got not much room between your electrical infrastructure and your fence. You can put the infrared beams in place, and they'll be contained in, just between the posts. Relatively middle range of costs, I would say, with a lot of variation in that range. Considerations: they are affected by snow, fog, and heavy rain. And affected means that typically your probability of detection will be reduced, or in extreme cases, actually the system will be fooled into seeing, thinking that there's something blocking the beam, and you'll get a nuisance alarm, or at least an out of service indicator. If the clever ones would know that it's just out of service, it can't see enough to actually give effective detection. So that's a consideration. These systems need numerous emplacements with stable footings. As you can imagine, the transmitter and the receiving elements need to be aligned to a reasonable degree, so that the light from the transmitter gets to the receiver. And if you have any kind of movement, frost heaving, and they get out of alignment, the system stops working, right? So that's a consideration with the active infrared systems. Electrostatic sensors, super specialized system that is really focused on protection for nuclear power plants. And if you've been around a nuclear power plant, you might see this array of wires on this rather threatening looking insulators. And what's happening here is that certain of the wires have a voltage and are carrying a voltage. It's a slowly varying static voltage, essentially. Other wires have voltage induced on them, on the sense wires, right? And again, like many of the systems, the issue is when a human comes near the wires, you affect that amount of coupling between the active wires that have the voltage put on them and the sensing wires which have the voltage induced on them. It's kind of like you're changing the capacitance, between the elements of a capacitor. The key advantage to this type of system, there are two. One is that it can be made very, very high. You can stack. There's 4-wire versions of this. There's 5-wire versions. You can, in each case, have one array stacked on top of the other to get detection heights up to 6.5 meters, 21 feet high, right? And which makes it very, very difficult for any kind of bridging operation by a potential intruder. And they're volumetric. Again, they're volumetric, and they have a quite tightly controlled detection zone, like approximately 1 meter, 3 feet to each sides of the wires. The main consideration is that it's expensive. That's why it's primarily utilized around nuclear power plants and really anywhere where they're, like outside of the electrical industry, anywhere where there is nuclear material, right? Sometimes you'll see it around prisons. So this is the electrostatic type of sensor. Also, just finishing off the considerations. Again, this one needs a nice tidy area, that's clear of vegetation. So if you need the utmost in security, this is the solution for you. Radar. So, everyone kind of inherently knows what radar is. We hear about it all the time. Not so long ago, limited to government and military usage, but now there are cost-effective solutions on the market that are used for perimeter security. And they have an element, the radar solution has the element of enabling to see beyond the fence concept, right? So you can have like alerts like pre-alarm conditions, when someone is approaching your perimeter, and then a second recognition when the person actually intrudes upon the line that you consider to be the property line. So it has that power, right, of seeing beyond the fence. In the top picture, there are the type is illustrating the type where the antenna is actually being rotated inside to give you 360-degree coverage, kind of like your classic airport radar, but smaller. And then the second picture here is showing what's called an electronically steered array. So there's nothing moving, but there are many individual transmitters and receivers, and through control of the phasing between them, there's a beam that is electronically steered. Typically through about a 90-degree range in azimuth, and 30 to 40-ish, in elevation. So a good effective coverage. And this is I would say the electronically steered are the new age ones, I would say. So what are the pros? Well, as I mentioned, you can get early detection of potential intruders, get that early alert, and then you can track them. And not only it's not just a simple line of detection, you track them through the volume of space, and you can know exactly where they are because these devices are ranging, to good accuracy, probably 1 meter, 3 feet accuracy in terms of range. So you can track to know exactly where that intruder is. Considerations, well, it's a radar. It does not see through things, right? So it does not see through the structures that will be at an electrical facility, control sheds, transformers, switches, etc. So you can end up needing quite a few of them to get the coverage that you need. They are subject to nuisance alarms from blowing debris. You have to get that under control. And they can't actually cover like right up to the fence, because a moving fence would be a constant source of noise to the radar. So you have to have a range cutoff that doesn't go out as far as the fence. So it creates a little zone next to the fence where you don't have detection. And of course, that's where the intruder might go, because that's when they go into your facility, they will be typically near a fence. So this can be an issue to manage. Right? Before I move on, I'll just mention the bottom chart here, just showing different range options available on the market. There's a large and growing number of options to choose from in this technology. Video analytics, which has been steadily improving for decades, and now showing more and more capability, right? I mean, the basic idea is typically we have cameras on a high security site, take that camera image, process it, and do automatic detection of what's there, kind of mimic what the human eye can do. Because, we can see things in people and through cameras, make the computer do that. Not as easily done as conceived. It's a challenge. In terms of like the types, we often hear motion detection, and you can buy your doorbell cameras that have motion detection. And that can be nothing more than like moving blobs, something moved somewhere, right? It's not really very intelligent in terms of determining whether that's something of interest or just a shadow, a reflection of a car light, whatever, right? So there's basic motion detection. More and more people are, leaving that behind, and they're doing what are often classed as AI, artificial intelligence, enhanced analytics. Looking at sizes, trying to reject common problems like, reflections, etc. And also providing classification. Is it a person? Is it a vehicle? So there's a lot of good technology on the market to do this. Another variation in the video analytics is whether the analytics is done in the camera itself, with a processor, image processor in the camera, or is it done in a server rack, at the security operations center or in some central location? And the movement seems to be to the camera based. I think at one time, the camera based analytics were looked at as second class, but more and more, I think they're dramatically improving. The other variation is whether you use your visible light cameras or thermal cameras to do the video analytics. The thermal camera can give you a cleaner view in the sense that it's less subject to shadows from clouds, from reflections of vehicle lights, etc. But they're expensive, and if you have thermal cameras, they're going to be there pretty much only for the detection purpose, because you don't want to, like this is an illustration of a thermal camera. You can't really identify. So typically, if you have thermal cameras, you're still going to also have the visible light camera. So that's a consideration. So what are the deliberations over using video analytics? Well, it's good because it leverages camera infrastructure that's probably going to be there anyway, right? For any kind of high security site. It does give you tracking, of intruders once detected, so that can help the response activity. You can have the pre-alarm condition, so you can have areas that are, not threat level, but maybe someone is approaching, and then you can trigger deterrent actions like bright up those lights, push a voice down message in, do things like that. Considerations to get effective detection for visible light cameras, you need better lighting than you would normally require, just for a human to see what's happening. So that needs to be taken into consideration. Users aren't always satisfied with the probability of detection and nuisance alarm rate balance obtained, and that is simply one of the statement is made based on observations and feedback from customers that the promise also isn't always there, depending on the specific conditions of the site. So that's a reality. If you want to do your video analytics on thermal cameras, then the costs jump substantially because you're putting in cameras that are dedicated really expressly for the video analytics function. Moving on. So now we are into emerging technologies. Lidar, like radar, but using beams of laser light. And the picture here, if you watch it, see it closely, there's like the image is made up of dots. And that's illustrating the point where the LiDAR is making a measurement. It's seeing that there's something there, and it's getting a range of that thing that's there, right? So you can see with this level of discrimination how you can clearly separate people, from the backgrounds. So it has a lot of promise. In terms of types, there is kind of some globally different types. There is the mechanically rotated type, analogous to the radar, where the mechanism is rotated completely to cover the surroundings. Again, somewhat analogous to the radar, there's the beam scanned electro-optically. Systems where there's nothing absolutely moving whatsoever, but there's a mechanism to control the positioning of the beam. And then so-called flash types that illuminate in one go the scene and then process the return image into a 2D sensor, which is actually, I think, kind of in the latest iPhone, there's that kind of technology, but obviously with a shorter range. So what are the goods and bads, or the pros and cons considerations? Well, there's a lot of promise in terms of what the system can deliver in terms of the probability of detection and the NAR balance, kind of as that picture kind of shows us. Has the potential, because of the discrimination and sizing capability, to classify objects. Is it a person? Is it a vehicle? Is it an animal? Bicycle, etc. Considerations. This technology, I'm calling it emerging. It's not by any means a proven technology yet in perimeter security applications. The existing systems are fairly expensive. Lots of potential to have lower cost systems in the future, but we're not there yet, excuse me. And the algorithms, the integrations from one system to the next, not quite there yet, but it's definitely something to keep an eye on. Another thing to keep an eye on is the concept of sensor fusion. The idea of taking data from disparate systems, two separate systems, and effectively merging it together to get a resultant system that's way better than either one individually. So, and this, for instance, where the concept is showing, use the data from your vibration sensitive fence sensor and from your video analytics, merge them together at a very low level to understand more, to have a better reading of whether there's truly something there of interest or not. So you can get potentially a much better PD-NAR balance. Okay, so I think that's kind of done with the technologies. So remember, detect, delay, respond, etc. Well, we're back to that. Delay, once someone is detected, you need to have some delay so that they can't just grab and go. And again, this is primarily fences. I mentioned that the strobing illumination can have a momentary inhibiting effect on the intruder, but mainly it's your fences, your bollards, walls, etc. Assess. And we're kind of assessing this presentation and winding it up a bit. Gather all relevant information and present it to the security staff. So what are the elements? If you have a video management system, you want to collect the right video and present it to the right operator security staff screen. In the classic security management concept, you want to show on a map, where the event is happening. Allow the operator to take control, to do voice down messages, show instructions to the operator so he knows what to do, and record his action. So for incident analysis after the fact, you can know who did what when. And then there's electronic access control system. Display the state of your access control mechanisms, gates, doors, locks, and invoke procedures, either go into lockdown or open up, if people need to egress. So where is this heading? This is heading to what is, all these labels there are the same thing. It's a unified security platform, a common operating platform, a physical security information manager, a unified system, single pane of glass. That's what people actually want, and this is what is now more and more the norm, to put in place, one system that does all of that, right? So that you don't have these disparate systems and have to integrate them all together and, maintenance, etc. Okay, so communicate, and I think I need to speed up a bit. So basically, in one line, get the right information to the right people at the right time. And, this is where things like mobile apps come into play so that your, mobile force can see what's going on. They can actually contribute to the overall situational awareness by feeding video from their phones back into the system, let other people see it, et cetera, et cetera. And then respond, again, have a guard force, but response can also include post-incident analysis, sending video information out as evidence so people can see what's going on, what happened. So summarizing, we talked about the different security elements. We talked about the multiple technologies that can, support all those, layers of detection of security elements. And we didn't talk about it so much, but it's evident that integrated solutions, improve the operation and the event assessment and response capabilities. So that is me done. So thank you very much, and I do note, Randy, that I probably took a little more time.
No, that's fine. Stewart, we have some questions here in the chat. First question was, thank you very much. First of all, thank you very much for the excellent presentation. The first question is, can you please speak about copper theft and what are some of the ways to prevent it?
Okay, so mainly I would say the first thing that people would jump to mind, obviously, are much of the things we've talked about, right? Put some security in place. Do you want cameras? Most people are going to, if they're concerned with, well, if to solve the physical security problem, typically you need a camera system. If nothing else, for assessment and for evidence of what's happened, right? So that's typically the starting point, right? Then very quickly you get into some kind of detection system, right? How do you want to know that something is going on, right? And it's kind of all those things we just talked about. A fence sensor is a very effective, cost-effective, and very functionally effective way to get awareness that someone is intruding into your site. Works well with the cameras. It can activate the cameras. You can go with that combination lighting approach if you need to improve the lighting. So it's kind of all of the things that we talked about.
Mm-hmm. Okay, is the intention Dave Bell, who's our next presenter, he's asking this question, is the intent, if there is a breach, regardless of the sensor, that the video feed will go to the grid operations?
Yes, I would say that. Yeah, there's going to be a security operations center, and whatever triggers the alerts, an appropriate video, presuming that there is an appropriate camera, will be sent.
All right. Dennis Sharma has asked, do the grid operators get the detection alarms, or are the alarms local?
Oh, no, the operator gets it. I mean, and again, this is a whole other subject that we, whole other topic of how you stitch it all together. But I mean, most people fully expect and get at the end of the day that that the alarm the whole awareness is going to a security operations center somewhere, right? Now that brings into question, like, how do you achieve that communication, right? Do you need to go with cellular? Is it built in? You know, is it already there as part of the operating equipment, or does it need to be added? You know, so that's a whole topic in itself of how you get that communication in place.
Okay, and there's another question here from Rudy Allegre. In terms of cybersecurity, is there a new guideline and who provides it?
I think there's multiple, but I mean, in North America, NERC, you know, that same, the same, I mentioned earlier, a standard that they from NERC to do with physical security. They have multiple standards to do with cybersecurity, and quite correctly, you know, it's a very astute question, because that's super concern, you know, for everyone involved. Right?
Sure, cybersecurity is evolving. As the threat evolves, the response evolves, and the standards evolve. I think, you know, 10 years ago, cybersecurity wasn't what it is today, and in 10 years from now, it'll be much different.
Yeah, and I'll simply say that we're pushing down the cybersecurity aspects into our sensors, right? So we're taking steps to make them cyber secure, so that they, you know, grid operators are comfortable with having them attached to their networks.
Great, good. Okay, so that was the last question that we had. So thank you very much for the presentation and the answers. Thank you for your questions, everyone who sent those in. Dave's turned his camera on now, and so